Yes, welcome to the YouTube video lectures for the physics course GES 132 Fundamentals of Physics. Today we are going to do the tutorial of that chapter we just finished. That was chapter number 15, Electrostatics, Electric Forces and the Electric Fields. So actually this tutorial session reinforces your knowledge and your practicing skills. It improves your skills, in fact. So let's do question number 1. An electron is accelerated by a constant field of magnitude 300 Newton per coulomb, given the charge on the electron 1.6 times 10 to the minus 19 coulomb, and the mass of the electron is given to you 9.11 times 10 to the minus 31 kg. Find the acceleration of the electron. Alright, so you know that first of all you have to find out acceleration of the electron. We know that E is equal to electric field intensity is equal to force, Coulomb's force divided by the charge. This is, you know, the electric field intensity E, or the electric field strength E. This gives you force is equal to charge multiplied by the electric field strength, capital E. According to Newton's second law of motion, this is equal to NA. It gives you A is equal to Q multiplied by E over M. M is given to you, E is given to you, Q is given to you. So substitute the values. Q 1.6 multiplied by E 300 Newton per coulomb, and the mass of the electron. So you get finally A is equal to how much in meter per second square? Yes, 5.27 into 10 raised to the power 13 meter per second square. So this is the acceleration of the electron when it is accelerated by a constant electric field of magnitude 300 Newton. So this is your answer. Next question. All right. Sorry, number 2. Question number 2. Consider 3 points Q1, Q2, Q3 are as shown in the figure along the x-axis line. Find the resultant force exerted on the charge Q2. So this is, you know, the charge under consideration. So you have to find out the force on this charge due to these two. You see, this is negative charge, this is positive, this is positive. Distances are given to you. This is 5 meters between these two, and this is 1 meter between these two charges. So, you know, we have to find out the resultant force on Q2. You have to find out. That resultant force is equal to sum of these two forces. So simply using, you know, the Coulomb's rule, which is force on charge 2 by 3, it attracts it on the right side, so positive, and this to the negative side. So keep in mind, we add the vectors, these forces like vectors. I mean, if a force is along the positive x-axis, we take positive. If along the negative x-axis, we take it along the negative x-axis, so negative sign. So simply, the key idea is Coulomb's electrostatic force is equal to K times Q2 multiplied by Q2 or R squared. This is the Coulomb's force between the two charges. So you have two charges, 2 and 3 first, and then again we use the same rule for these two charges. Actually, we are going to find out the force on this charge due to this, and the force due to this Q3 on Q2 here. And we already decided the directions, and then we use the rule. K, electrostatic constant, Q2, Q3 over R23 squared minus K, Q2, Q1 or 2, 1 squared. You have, K is common. It will be given to you that use K is equal to 9 times 10 raised to 9 Newton meter square per Coulomb square. It will be given to you. Right, 9 times 10 raised to 9, it is common between the two. Okay, then you have 2, 5, micro minus 6, microcoulomb is minus 6, 10 is minus 6, Q3, 8 minus 6, or R23, this is R23, this is R21, so this is 5 squared minus Q2, 5 microcoulomb, Q1, 2 microcoulomb, or R21 squared, which is 1 squared. So finally you would get minus 0.076 minus 0.076 Newton. So this is your answer for this force, resultant force on the charge, which is here. Next question. Yes, number 3. An electric field of magnitude is given to you, points due south. So these are the directions. Right. So it's due south. Okay? Electric field this direction. Okay? At a certain location, find the magnitude and direction of the force on negative charge at this location. You see, you know that electric field strength has the direction from the positive outward and negative into. So what does it mean? It means you can think of like this one, for example. Right? So from the positive plate to the negative plate, this is the direction of the electric field strength or electric field intensity, capital E. If you have a negative charge at this location anywhere, what will happen? This is negative charge, this is positive, so it will be attracted to this side, right? Because, and also this is negative charge, so they will be repelled. It will be repelled by this negative plate, so upward. So the direction of the force is upward. Upward means this is north. So direction of force F on negative charge at this location is due north. This is about the direction. Done. Now the magnitude. Magnitude of force is calculated by this rule, right? Keep in mind this is the magnitude, okay? So what is the magnitude of the charge? It is 6 times 10 raised to power minus 6. And magnitude of electric field, this is your electric field strength. So 5.25 10 raised to power 5. So you get finally the magnitude of this force at the location, given location, 3.15. This is your answer. This is the magnitude, and this is the direction. Next question, number 4, please. Three charges are arranged as shown in the figure. Find the magnitude and direction of the electrostatic force on, on which charge? On the charge 5 nanocoulomb. Nano means 10 to the minus 9. So let me call it Q1 and Q2, and then this one, let me call this Q2 rather, and this Q3. Distances are given to you, right? So you have this charge Q2, the charge of interest. So you have to find out the force, resultant force on this, right? So you have to find out the force, by this charge and then by this charge on this Q2 and find the resultant. Right. You see, keeping in mind the rule for the direction of the electric fields, electric force, and the direction of the electric field lines, in fact, we see that F12 this direction and F32 the force on charge Q2 by Q1 this direction, right? And the force on charge Q2 by Q3 along this direction. You see why? Because this is the point of interest, right? And this is positive charge outside this one. And this is negative charge, into this. So this is negative charge into this, right? And this is positive charge out of it. So if we use the head to tail rule, this is F12, bring the beginning here of the second vector. This will be your resultant direction. This is the resultants. And this will be the angle theta, which is below. This is positive x-axis, this is negative x-axis. So the theta angle is below negative x-axis. Keep in mind, we will discuss when we discuss the direction, you will see that one. Now, we have to calculate, the magnitude will be equal to, by Pythagoras Theorem, magnitude will be equal to F12 square plus F32 square under the root. This is the magnitude. So it means first you have to find out F12 by Coulomb's law, and similarly by Coulomb's rule F32. So let's calculate those forces first. F12 K Q1 Q2 over R1 square. Alright, so 9, it will be given to you 9 times 10 raised to power 9. K will be given to you okay, 9 times 10 raised to power 9. Q1 how much? 6 nano minus 9, and Q2 5 nano again minus 9, or R square 0.300 square. So you would get F12 3 times 10 raised to power minus 6 Newton. Similarly, for F32 you would get K32 over 2 square. You have 9 10 raised to power 9, Q3 3, keep in mind we are taking the magnitude right now, minus 9, Q2 5 nano minus 9, and divided by R square, which is 0.1 meter square. So you would get here 1.35 minus 5 Newton. Right? So the magnitudes, as I told you, will be F12 square plus F32 square. So you have F12, how much? Minus 6 square plus you would get the magnitude of the resultant force on charge Q2 will be 1.38 into 10 raised to power minus 5 Newton. So this is the magnitude. And for the direction, we use tan theta. So theta is equal to tan inverse from this triangle, tan inverse F32 over F12, which is tan, let me write it here, tan inverse F32 divided by F32, this one 1.35, and 1, 2, 3 times 10 to the minus 6. So you would get theta around 77.5. Keep in mind, as I told you, this is below negative x-axis. Okay, that's it. Next question. Yes, three charges. Three charges are at the corners of an equilateral triangle, mean their sides are equal, 0.5 meter of length. Calculate the electric field at a point midway between. This is the point where you have to find out, the electric field strength. Okay, so right now, you see, we have to decide the directions first of all, right? You have this charge positive, this charge negative, and this charge positive, right? Okay. Now, as you know that from the positive charge, all directions outward, the electric field strength, and the negative charge inward from all directions, spherical directions, right? But we take only one direction here, not all direction. We take the direction for the point under consideration. So this is the point under consideration, the point of interest for you, where you need to find out resultant electric field E due to all these three charges at the middle of these two charges. So you see, this is Q2, right? Positive charge. This is the point of interest. So all direction positive, but I take only this direction. So E to this direction, positive x-axis. And this is negative charge. You see, again, negative charge, all directions inward. But since I take only this point of interest, so it will be this side again. So this is 3. Now, the third charge, which is Q1, positive. Again, this is the point of interest. So all directions outward. So I take only this point. So this is your E1. So these are the directions which are really very important to decide first. Otherwise, you'll be getting wrong result. Right. Now, we are going to find out E. The key idea is K Q over R square. This is the key idea, right? We have to find out the resultant. So we have E1, E2, E3, and we will find the resultant magnitude. So first, we find out E1, KQ1 over R1 square. All right. You see, this is Q2, so this is R2. This is Q3, so this is R3. So this is half the same, right? This is R1. I can find out by using the Pythagoras Theorem, right? This square, R2 square plus R1 square is equal to 0.5 square. So I can find out, you see, R1 square plus R2 square, 0.5 square. I need, in fact, R1. So R1 square is equal to 0.5 square minus R2 is given to you. So minus 0.250 square. So this is R1 square. So after taking the square root, you will find this one R1, right? So E1 you will get K. It will be given to you again 9 times 10 raised to the power 9. Q1 3 nano. R1 square. So you get, 144. This is E1. Similarly, E2, 9 10 raised to power 9 times Q2 divided by R2. Okay, Q2 how much? 8 nano, and R2 0.250. You would get E2 1.15 times 10 raised to power 3, right? And finally, E3 you would get, again the same rule by the way, which is KQ3 by R3 square. Again 9 times 10 raised to power 9, which is K, constant value, Coulomb's constant. Q3 how much? 5. We take only the magnitudes, not negative, keep in mind, divided by R3 0.250 square. So you would get E3 719. So these are three values. This is E3, this is E2, this is E1. Now you see what we do. Can I go to the next page please? Okay, you see this is along positive x-axis. You see this one, positive x-axis. This is along negative y-axis. Okay, so they E2 and E3, they don't have y component. Y component is 0. Similarly, x component of E1 is 0. Exactly, the E1 is towards the negative y-axis. So what we do, first I find x component of the resultant and the y component of the resultant. How x component? These x components are along x-axis. You have these two, E2 and E3. Okay, so both are positive. Okay, you write down their values, E2 and E3, 1.15 plus E3 719. So you would get EX 1.87 10 raised to power 3 Newton per Coulomb. Okay, I'm sorry, these are mixing. Okay, let me write it again for you. So this is E2, this is E3, both along positive x-axis. Okay. Now similarly, y component. Y component is only 1, right? So I can write the y component of the resultant electric field intensity E is, y-axis only E1, negative y-axis. Okay, so minus E1, which we calculated on the last slide, which is minus 144. Now, once you have, you see, x component of the resultant positive and the y component is negative, So you'll be having Ex, Ey, this is E resultant. I'm using according to this data. Ex is positive, I take this positive. Ey is negative, I'm taking the negative. So you would get, by Pythagoras Theorem, Ex plus you get the resultant electric field intensity between these two charges on the x-axis will be 1.88 to 10 raised to power 3 Newton per Coulomb. So this is the magnitude. Right. Okay. And for the direction of E, we use the same triangle, tan inverse Ey over Ex, which is tan inverse Ey minus 144 Ex 1.87 10 minus 10 to the power plus 3, sorry, and you would get theta is equal to minus 4.40. This is becoming minus because it is below positive. This is positive x-axis, so it is below positive x-axis. This is your the angle. Next question, number 6. The figure shows electric field lines for 2-point charges. Find the ratio. Find the ratio between the magnitudes of these two charges. You see, once we discussed the chapter, I told you that once you have the electric field lines going out of the positive charge and coming into the negative charge, you see the number of lines is giving you the information about the magnitude in the given unit, by the way. Right now, you have, Q 1 by Q2 this ratio. That's it. Because you calculate Q, start from here 1, 2, 3, 4, 5, 6, 7, and 8 going out, and coming into, you see, you can calculate 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Q1 8. And Q2 going out, start from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, total 16. So for the Q1 8 coming into and going out of from Q2 16. So the ratio is 1 by 2. Next, fill in the blanks quickly. The electric force between the two charged particles is directly proportional to the product of, the magnitude. This is what we discussed. Magnitude. The product of the magnitude. And then inversely proportional to the square of the distance between the two. Similar charges repel each other and the different charges attract. Unlike should be, by the way, this is unlike charges, like charges. Okay, the electric charge. The number of electric field lines giving or entering a charge is proportional to the magnitude of the electric charge. This is what we just discussed in question number 6. Now, Coulomb's constant unit is Newton meter square per Coulomb square. Electronic charge, is the unit is Coulomb. Coulomb's law, electric force between pair of charges, this gives you, and the electric field is equal to, electric field is equal to force on a charge. So this is end of the tutorial, and thank you very much. Good luck.